talk a minute. So quizzes for third period were pretty good. Congratulations. I will say fifth and seventh period exponentially decayed. Like pretty bad scores. So do me a favor. Do me a favor. So some of you still want me to test a quiz. Some of you needed extra time, which is fine. I would like to make sure any of that's done by Friday next week. So a week from tomorrow. Good? We don't have school Monday, Tuesday, right? Everyone still following me on this? Now, I don't offer this often, but when I do, I just want to make sure it's very clear that what frustrates me when students do poorly on a quiz, wasn't this practice test very, very similar? Some of you realized it. And some of you even watched the video to ensure that you knew it. Okay? And it was obvious. It was very obvious. But unfortunately, there are some, and there's not as many in this class as other classes, but there are still some in this class, that are putting answers that are not even remotely close. You don't even have X as part of your answer. Like, people are putting like just arbitrary numbers. You're picking numbers from an infinite region of numbers, and you're just writing them down. Like, there's an infinite amount of numbers, but I'm going to pick the number 7. Well, there's 7 is nowhere part of the answer. You don't even have X's. You don't even have parentheses. You don't even have it if it's solvable. So, if you take a look at your test or quiz, and I graded whether you were done or not. And if you weren't done, that's one thing. Your grade stinks, but to come make it up by Friday next week on one of your off periods. If you feel that you could improve your score, you have until Friday of next week to come in on one of your off periods. I will give you your test, and I will give you point per point back as long as you get it correct. Deal? Yeah. Now, let's see. Today is Thursday. We took the test on Wednesday. Is that right? That means that on Tuesday's video, at the very end of it, I went through this this week, right? We have school Tuesday, right? Oh, next Tuesday. You're absolutely right. We don't have school. So, if you go back to the video from Tuesday's class, it's like a 40-minute video. If you go towards the end of the video, I do work out each and every one of these problems. Okay, now one of them I think there was a mistake on. I'm not going to make that. One mistake, sorry. I don't think I had the right factors. I think it's 3 and 7 is supposed to be 3 and 8. Is that what? Okay. It happens. But for the most part, if you would like to take one of these, you already have one, but if you'd like to take another one and practice, and then come in, regardless of what your score on the test. I mean, I had some people who got 60 out of 61. Okay? And you're like, yeah, but you said it's only out of 60. Yeah, because my highest score, I had 12 students in all my classes that got 60 out of 61. So I made a 60 the highest score. So it appears you got a perfect score. So if you got a 60 on this test, if you're like, dude, I know I can get that 1 point back, if you get that 1 point back, that counts as extra credit. And y'all have been here long enough to realize we don't give a whole lot of extra credit, right? There are some of you that have scored as low as, and not necessarily on this class, but I had some students that scored as low as 1 out of 60. That's a gift. That was a gift. That meant everything was so wrong. It's like, you know what? At least they realized they're in math and they put a number someplace. Give you 1 point. Yeah.
Or maybe that they knew the right answers, so that the only way they get them all wrong is they knew all the right ones.
That's true. That could be. That could be. So, friends, if you fall into that category, and some of you might look at your score and say, you know what? I got 58 out of 60. I'm totally fine with that. But if that person with a 58 out of 60 wanted to try and earn 3 points directly back, you have until Friday, next week, not tomorrow, next week, that you can come in and make it up. So, does anybody want one of these sheets to study from? You already have it, but if you wanted another one, does anyone need one? Okay, come grab one if you want one. And you know where to find the video. Does that make sense, where to find the video? I'm not saying go watch the 40-minute video. I'm saying go to the last part of the video, go through that, make sure you feel comfortable with them. Come in on one of your off periods. It doesn't matter if I'm teaching. Come in on one of your off periods. I will give you your test back, and you can redo your test. Now, here's one extra. Here's one extra little leaflet. Listen. If you have this sheet, whether it's the old one or this one, they're both the same. When you come in, you are welcome to bring this sheet with you and use it. Does that make sense? So the kid who comes in and your sheet that is the PEF practice test, you're like, hey, I have that, and you have it blank. A blank sheet doesn't help you. Yes? Okay, so that's my deal. Make sense? Does everyone? Yeah.
Well, I was gonna say, because I didn't finish mine yet.
Yeah. Bring it. So you can use it. If you didn't finish it, I'll let you use it. Cool? That deal?
Yeah.
Yeah. I'm giving you yours back, so all you're going to do is you're like, oh, I missed number 3, so you're going to rework number 3. Does that make sense? Yeah, you don't have to do it all. No, just what you missed. I actually give you your test back. I give you a test back. I give you your test back, and you get to take care of that, okay? Is that a deal? If you didn't finish, you can still, if you didn't finish, you still get to use that sheet on it, okay? So again, let's recap, and then I'm going to get into today's lesson. Let's recap. Test is in the grade book. The test was out of 61 points originally. The highest score I got was a 60, so I made it 60 in the grade book. So if you got a 60 and you want that one extra point, then come on in and all you have to do is adjust that one. If you didn't get done with the test or quiz, if you want to make points up, you can take one of these sheets that you already have. You can go to Tuesday's video. Still follow me? You can watch that video and help you out. Go to the last part of it. Don't watch the whole 40-minute video. I mean, you're welcome to watch it, but just go to the problems that deal with that worksheet. You can fill out anything on that worksheet you want. And you already have this, and somebody came and grabbed an extra, which is fine. Whatever you write on this sheet, you can use directly on the test that's not made up, or if you're earning, or not completed, or if you want to just earn points back. Does that make sense? So what's wonderful, what I love, is there's quite a few of you that earned in the 50s. And I'm going to get you, you're going to come back in saying, dude, I want to get all my points. I love that. What's frustrating to me is the student who is struggling and they don't come in. And then after next week, I get an email from a parent saying, hey, my kid's doing really poorly. What can they do to improve their grade? Well, one, this is being recorded, so I'm going to direct this recording to your parents. And your parents are going to be like, your teacher said that you could come in on an off period and use anything that you wrote on the sheet of paper that he gave you about the video from his thing, and you could use that on the test, and you chose not to? I don't know how that conversation is going to go at home, but I know that if my kid, either one of my daughters, if they had that opportunity and they didn't take that opportunity, Dad and Mom will both have conversations. Now, Dad's the wimpy conversation in my household. Mom is the hammer. So just make sure that is for you, okay? All right, so my friends, would you do me a favor? Would you turn in your books to page 79? Page 79, please. Everyone find where they go? Page 79. And let's see, we are out here at 55, so we got time. Okay. So, what page was it? Page 79. Thank you. I'm on page 79. Y'all with me? All right. Page 79. So, friends, we have graphed lines. These are all lines. We graph all these lines, right? We've done this before. We've done this quite a bit. So now, we're going to move away from graphing lines to graphing these things that have x squared in them. Now, friends, please trust me. I think you do. Some of you trust me. Some of you are doing quite well with me. So I think either you like me or you have a really good tutor or somewhere in between. I don't know. But I'm going to show you a method of graphing parabolas. That again, remember when I did factoring? We did factoring all the same way, right? You know, if you have this x squared, oops, x squared plus this, plus that, or minus that, or plus or minus or whatever. We did it the same way over and over. So with that, I want to make sure we have the same thing. Okay, so there is an awful, I think you have this page. You might not have the colors. Okay? So notice they have general form of a quadratic is ax squared plus bx plus c. A, b, and c represent the numbers. So far we've done factoring problems where it was like, hey, yeah, 2x squared plus 7x plus 15 or something like that. Yes? So that's the same thing. The a, b, and c is the lead coefficient. A lot of times if you just have x squared, what number were we putting in front of x squared when we were factoring? A 1. So there's a 1 that's always could be a part of these problems. Okay? Now, there's some other things that we're going to talk about that go with a parabola. Now, the parabola has a minimum point or a maximum point, depending upon if it opens up or down. Let's just clear the way. The math that you're going to do for the next couple years, your parabola is either open up or down. Can parabolas open right or left? Yes. You're not going to see them up through Algebra 2. Okay, so they will indeed open side to side. That's fine. We're not going to worry about those. But we have some things to know. A parabola is symmetric about a certain vertical line. That vertical line is called the axis of symmetry. The axis of symmetry goes right through something called the vertex. The vertex is a point. The point has an x and a y value. Make sense? There are times that your parabola will indeed cross the x-axis. Where it crosses the x-axis is called a solution. If a parabola crosses the x-axis, it doesn't always have to cross at exact points. Okay? But if it crosses at a point, if it was something that you could factor, you could actually find the exact points of where it crosses. When you are factoring and setting their factors equal to 0, that's the point where it would cross the x-axis. Where it crosses the x-axis, they are called solutions. Sometimes they're called roots. Sometimes they're called zeros. All three of these terms right here mean the same thing. It just means, hey, where is it crossing the x-axis? If it's crossing the x-axis, I should be able to plug that point exactly in, that x value exactly in, and I should get 0. Okay? The axis of symmetry goes right through the vertex. The vertex is a point. There is a y-intercept. Okay? All parabolas that open up or down do indeed have a y-intercept. Not all parabolas that open up or down cross the x-axis, so they don't always have solutions or roots, okay, that are real, part of the real number system. Okay, is everyone following me so far? Now we have the survivor mode. I don't know if you have this page. Is this on the second page? No. Okay, is that? Yes. Cool. So remember we said there's A, B's, and C's. And the A falls right in front of the x squared category. The B falls right in front of the x category. And the C is the number that doesn't have an x attached to it in some form. So if I use y equals ax squared plus bx plus c, where A, B, and C can represent numbers. And remember, A many times can be equal to 1 when we just have x squared standing alone. There's technically a 1 in front of that. Okay? So, finding the x coordinate of the vertex. This is the equation that we will always use. Okay? You have a negative, that's part of it. You have a number 2, that's part of it. And then you have a b value, which is attached to our x. And we have an a value, which is attached to our x squared. And a lot of times that a value can be 1. Okay? The axis of symmetry is the same as this. So the axis of symmetry is this equation as well. Okay? Now, you can make a table of values, which is great. And a lot of times, table of value is a survival skill on a, some standardized test. I don't know what this graph looks like, but maybe I'll plug 0 in, maybe I get a value out, maybe I'll plug 1 in and get a value out, maybe plug 2 in and get a value out. And that's great. The y-intercept is always 0, c. Do you see a c value in our original equation? Is this a c value? So that value and that value are the same thing. So 0, c is where it crosses the y-axis. The y-axis is the vertical component. There are points that we can do. Parabolas form a smooth curve. They have a turning point, which is called a vertex. The vertex can be a minimum value or it can be a maximum value, depending upon if it opens up or down. Okay? So I'm going to go to here. Okay? Now, please trust me. Please write down what you need to write down. So things that we know that we're going to have. We're going to use negative b over 2a. Negative b over 2a. Okay? That's where we will start every problem. I'm also going to start every problem. I'm going to say that a equals 1 because there's a 1 out front here. B equals, what do you think? 2. And C equals, careful, watch the sign. Negative 3. Okay? So right now, on my stuff, my y-intercept I said was 0, what letter? 0, c. So what's my c value? Negative 3. So 0, negative 3 is here. And we're just going to plot this. We're just going to plot this point right here. Okay, now that's just a point. Okay, it's not going to dictate whether the parabola opens up or down. That's just a point. Agree? So, remember that negative b over 2a? So, I have a negative. That's part of the equation. Agreed? What's my a value? Or excuse me, what's my b value? 2. Over the 2, because that 2 is here. What's my a value? 1. So that's negative 2 over 2. And negative 2 over 2 is equal to what? Negative 1. Okay? So right in the very middle of my table, I'm going to plot negative 1. Okay? So I know that my equation was this. My equation was this. This is an x value. So what do you think I should do with that x value to get my y part of it? What should I do with this x value here? What should I do with this in order to get the y value out? Because this is y equals. Plug it in. So I'm going to go negative 1 squared plus 2 times negative 1 minus 3. Okay? Where those negative 1s are is where x's had taken place. Anytime I'm going to plug anything in math, I'm going to put it in parentheses. Is that okay? Still following this adventure? Okay. Now, we have to use a little critical thinking here. Negative 1 quantity. Quantity means I'm using parentheses. If I take negative 1 and I square it, that becomes negative 1 times negative 1. What's negative 1 times negative 1? Positive 1. Okay? And then I get 2 times negative 1. What's 2 times negative 1? Negative 2. And the minus 3 comes along for the ride. So this is what y equals. So now we have to do the math. 1 subtract 2, negative 1. Negative 1 subtract 3, negative 4. Friends, this very center point here, we're going to call our vertex. This is one of the turning points. This is the only turning point in a parabola. So we're going to plot that point. 1, negative 4. Negative 1, negative 4. Okay. Now, is there anything that I have done so far that you're not quite sure about? And I'm going to put this under my vertex as well. So notice, where did I put the vertex on my table? Is it right in the middle of it? So there's stuff to the left of the vertex and there's stuff to the right of the vertex. Does that make sense? Okay. Other things that I can label on this graph. Do I know the vertex? The axis of symmetry is always going to be x equals. The axis of symmetry is always going to be the axis of symmetry is always going to be the x component of the vertex. Okay, so it's x equals what? Negative 1. Okay, so x equals a number is always a vertical line. Make sense? So I'm going to draw my axis of symmetry right here. Notice my axis of symmetry goes right through the vertex. You feel okay with that? So what the axis of symmetry is that is the line. If I could fold over my computer, which if I did that, it's going to break. But if I could take my computer and fold it over on top of itself, it becomes a mirror image on both sides. It's like your two hands. If you take your two hands and you do this, if the edge of your palm is the axis of symmetry and you put your hands together, your fingers match up. Agree? That's what the axis of symmetry is doing. So what it does on one side, it does on the other side. Now, I'm going to show you something that takes off 2 lessons from now, but I'm going to do it now. In order to pattern graph, and pattern graphing is going to become your best friend, it is the A value times 135. Okay? 135 always will be used. Okay? Friends, what is my A value? 1. So I'm going to go 1 times 135. What's 1 times 135? Well, 1 times anything is itself, right? It goes 1, 3, 5. So this is our pattern graph. Ready? Help me out. What's my vertex? What's the point? Negative 1, comma 4. So from my vertex, I'm going to do this. Ready? Ready? Put your pencils down. I'll give you time to write this. Ready? I'm going to go from my vertex. I'm going to go right 1, up 1. Go back to my vertex. I'm going to go left 1, up 1. Okay? I established those 2 green points. Now, can you see how those 2 green points, if I were to fold over that red vertical line, they would match up on top of each other? So there's symmetry about this. Okay, in order to get another point, I'm going to go for my new points. And I'm going to go right 1. In this case, I'm going to go up 3. And I'll go for my other green point. I'm going to go left 1, up 3. Okay? The next number would be 5. Now, we do 135, but it's 13579. It keeps going. It's all the odd numbers. Okay? You get to a point sometimes with these that you can't go too much further. So if I wanted to find one more set of points, I'm going to go for my new points. I'm going to go right 1, and I'm going to go up 5. And I'm going to go left 1, up 5. And I have enough information here to draw my parabola. Now, friends, if you pattern graph on a grid, can you figure out what the points are? Like this point looks like 2, 1, 2, 3, 4, 5. 2, 5. This point here looks like -1, -2, -3, -4, -4, 5. Can I find this point here? Is this point right here? Is that the point 1, 0? And if that's the case, is this point here -1, -2, -3, -3, 0?
And if I could do that, I knew my vertex, we had already labeled the vertex as this point right here. Our vertex was -1, -4. So I could find this other point here. This point here is 0, -3. This point right here, if I count, -1, 2, -2, -3. Is there enough information there to fill out the rest of the table? Yeah. To the right, I go to 0, -3. To the left, I go to -2, -3. If I go one more spot, I get to 1, 0. If I go to the other way, I get to -3, 0. Okay, I just use these points here to establish that table. Friends, we've just drawn our first parabola. They're done the same way every time. Yeah.
Are there gonna be like multiple of those? No.
On one graph?
Yeah.
Probably not. I'll try not to have multiple ones on one graph. Each graph will have its own. Cool? All right. So, roots. All right. Let's see who's listening in the beginning. A root was a solution. It was also a 0. So a root is where it crosses the x-axis. Where is this crossing the x-axis? What points? -3, 0 and 1, 0. Those are my roots. Okay, you know you're dealing with a root when the y value is 0. Ooh. When the y value is 0, you're dealing with a root. Yeah, baby. Is there anything else on that? We did it. We have everything. All right, so the order we're going to do things. We're going to write -b over 2a on every problem. We're going to write a equals b equals c equals on every problem. And we're going to use pattern graphing as a times 135 on every problem. Hey, what do you think would happen if my a value was negative? What do you think the graph's going to do? Is it still going to open up, or is it going to do something else? It's going to be upside down. It's going to go down. So if my a value is a negative value, my graph opens down. Okay? As long as a is positive, opens up, doesn't matter what the signs in the rest of the problem are, it's going to open up. If a is negative, doesn't matter what the rest of the signs are, it's going to open down. Okay? So that's a good amount of information. Friends, can I move to the next slide? And again, I'm doing it the exact same way each and every time. Agree? Okay. What's the first thing I'm going to write down? -b over 2a. And friends, some of you are like, do I really have to write it down? Trust me. The more you write it down, the more accustomed you're going to do with parabolas. You're going to see parabolas not just in my class. You're going to see it in science classes. Okay, it might not be in biology. It might not be in chemistry, but you would see it in physics. Okay? A classic physics problem talks about braking distance of a car. Braking distance of the car forms a quadratic formula. Okay? Free fall. If I drop an object and it goes into free fall, it is a quadratic formula. If I throw an object up into the air and it's going to come back down. Now, some people could throw farther than others. It's still a parabola. A parabola means it's x squared. It might have a whole bunch of other stuff with it, but it's still x squared. Okay? All right, what was the next step I said that we're going to do with these? Okay, A, B, and C. What's my A value equal to? Watch the sign. -2. Still with me? What's my B value? 8. And my C value? Hey, friends, do we know what my y-intercept is right now? It's 0, C. So what's my C value? 0, -2. Again, this is just a point that we can make. Okay? That point might fall with our pattern graphing, which is fine. But we now have a point established. And a lot of times with parabolas, they want 5 points to be established. They want the vertex and then the mimicked points. So sometimes that y-intercept becomes a sixth point because our pattern graphing might not have incorporated it, and that's okay. All right, so I'm going to use that negative b over 2a. So I have negative, what's my b value? 8, good. Over 2 times, what's my a value? Negative 2. Still with me? So negative 8 stays on top. What's 2 times negative 2? Negative 4. Negative over negative is going to give me what? Positive. Okay, so it's going to be positive now. Okay, I don't have to put a positive sign, but we'll just keep it. What's 8 over 4? 2. Okay, my axis of symmetry is going to be x equals 2. So you're welcome to draw in your axis of symmetry. Sometimes it's written as a dotted line, which we'll do. That is my vertical line, x equals 2. Agree? What's going to live on my axis of symmetry? Starts with a V, ends with an X. Has ert in the middle. Vertex. My vertex lives somewhere on that pink line. Okay, right now, on my graph, I'm going to put 2, because that's my axis of symmetry. So let's figure out our vertex. So this vertex here and this vertex here should be the same thing. Okay, so my original equation was y equals negative 2x squared plus 8x minus 2. What should I do with my x component of my vertex to get my y component of it? Plug it in. So I get negative 2 times something squared plus 8 times something minus 2. Where those parentheses are is where x used to live. What am I plugging into the vertex? What was my x value? 2. Okay. 2 squared is what? 4. 4 times negative 2 is what? 4 times negative 2 is? Negative 8. Plus 8 times 2? What's 8 times 2? 16 minus 2. We're going to do the arithmetic. Negative 8 plus 16. Positive 8. Agree? Positive 8 subtract 2. So my vertex is going to happen at 2, 6. So we're going to plot this. 2, 6. So 2, 1, 2, 3, 4, 5, 6. I'm going to label it. Hey, friends. Should this parabola open up or down? Down. Why? The A is negative. It opens down. Does our graph, right now what we know, we have the where it crosses the y-axis, and we have the vertex. Does this make sense that it should open down? Because I want that point to be incorporated. All right. So, will you do me a favor? What's our next page in the homework? Actually, let's just stop there. I will continue this tomorrow. I won't give you an assignment tonight. But what's available for you, friends, by Friday of next week? Yeah, you're not retaking it. You're just fixing any problems. Doesn't matter what score you got. No, what can you use on it? That practice sheet. Have a great day. Take care of one another.